Hello class, welcome back. Today we're going to go ahead and continue our last section, which is going to be module K, right? Homework K, which consists of inverse trig integrals. All right, specifically this is section 5.7 of your book. Right, and on the cheat sheet that I have provided you guys, right, the list of derivatives and integrals to be memorized, these are going to be the bottom right, right? This is going to be the bottom right. Specifically, we're going to be looking at arcsine, arctan, and arcsecant. All right, those are the three ones you'll be seeing here. You may find a secant right here and there, but the majority of these are going to be tangent and sine, right? That's these here. These two you should have memorized. All right, where u, right, the variable u that is there, that is your variable, right? Whether you're integrating with respects to x or t or r, right? That'll be that variable. The a is just the coefficient. All right, it's just the coefficient, and we're gonna have to go ahead and notate these to keep track of everything that's going on, to be sure that we're providing the correct answer. All right. So I'm giving this integral here, right? You get to the homework, you see this integral. One thing you always want to do with these is whenever you're dealing with the variables u or a, right, that are mainly going to be in your denominator, you want to write them such that, in other words, 25 is the same thing as 5 squared. 36 is the same thing as 6 squared, right? So you want to rewrite the same number, but just with an exponent, right, being squared. Or whenever you simplify, right, it gives you that, right? Because we're going to get some scenarios where it's going to be a little bit different, right? Right, 9x squared, right? This is 3 squared times x squared, which is just 3x squared, right? So right, we would have to do something like that. Another one we'll probably have to do is, let's just say x to the 6th. This is the same thing as x to the 3rd raised to the 2nd power. All right. Whenever you have an exponent with an outside exponent as well, they multiply. Right. Right. They multiply, and the reason I need you to go ahead and do that, it's because once you have that, right, the formula here that you memorized is already in that form, right? It's already in that form. So all you would have to do is locate what your u is, what your a is, apply some u substitution if possible, and you just go from there, right? So in other words, this here would be the integral of 1 over the square root of 2 squared minus x squared dx, right? Where u would be my x, and where a would be, okay, your a is not going to be your 4. Remember, your a is not going to be your 4. Your a is going to be 2. All right, it is the number that's being squared. All right. At this point, right, you would go ahead and look at the formulas, all right, any of these three, and see one that has the square root, all right, the coefficient minus the variable under the square root, and you realize that this is arcsine, right? This is your arcsine, right? You may use, for your homework, you may use arcsine, or you may use this version of arcsine, right? It's up to you. All right, they'll both mean the same thing, but my open math only accepts the top one, right? Would only read the top one. All right, so meaning, hey, I'm going to use the first one. All right, so that's pretty straightforward. I don't need to know u substitution, know anything. All right, it's just pretty straightforward. So my answer for this would be arcsine of u. My u is x over my a, where my a is 2. Plus c. Remember, this is an indefinite integral. All right, plus c. Pretty straightforward, right? Pretty straightforward. Ooh, now we take a big jump, right? Now we take a big jump. Right, just like before, right? Not only am I going to rewrite the variables in the denominator, right? The coefficients in the denominator, but I'm also going to factor out that 3, right? This is a habit that we've already picked up. It just gets it out of the way, and it's easy to read my integral. All right, so in other words, this integral becomes 3 integral dx of the square root of 5 squared minus 4x squared, all right? That's what I have. Look what's going on here. All right, whenever you have a coefficient in there, all right, whenever you have a coefficient in there, I'm going to want you to use u sub. All right, I'm going to want you to go ahead and use u sub. So u is equal to 4x, meaning du is equal to 4 dx. Just like before, right? We can go ahead and rewrite this. Hey, I don't have a 4 dx. I have a dx, right? So let's go ahead and get rid of this value, right? So du over 4 is the same thing as dx, all right? So let me go ahead and make those. Substitutions. All right. So this is 3. That is not a 3. 3 integral of du over 4 whole over the square root of 5 squared minus u squared. All right. Very nice. Okay, what am I going to go ahead and do next? Let me go ahead and rewrite this top part, right? This is just 3 integral du over square root of 5 squared minus u squared times 1 over 4, all right? And hey, right, let me go ahead and factor out that 1 over 4, all right? I don't want that 1 over 4 there. So in other words, this is 3 over 4 integral of du over 5 squared minus u squared, all right? Because I did the u sub here, all right? And what do we think we should do next? All right, yeah, at this point, I'm free to go ahead and take the integral, right? I'm free to take the integral, right? So this is going to be, go ahead and zoom out for you guys. There you go, 3 over 4, all right? We going back to here, right? Whenever we did u sub, u equals 4x and a is equal to 5, all right? Specifically here. So at this point, hey, I can go ahead and take the integral, right? So this is going to be a square root 1, right? The square root that has to be arc sine. So this is going to be arc sine of u, right? Which is just that variable. That's fine. Over a, right? And a is just 5. See? But you know what u is, right? U is 4x. All right. So 3 over 4 arc sine of 4x over 5. C would be your final answer, all right? So, all right, so this is requires a little bit more steps, all right? Because there's u substitution, right, within it, right? But once you make the u substitution, it's just an identity, right? Just, hey, which one does it match? Which one does it look like? Is it the arc sine, arc tan, or arc secant? Right? We have another one, right? Right, we have another one. All right, so hey, this is a variable, right? That is a variable. I cannot factor out variables. I can only factor out coefficients, all right? So x to the 5th stays there. I cannot take that out of the integral. All right, so I'm going to go ahead and rewrite the denominator. This is 1 minus x to the 6th raised to the 2nd power. All right, I always want a base raised to the 2nd power. All right. Again, right, I would have to use u sub here, where u is, right, let's find a. A is just 1, right? Because 1 is just the same thing as 1 squared, right? So my a is 1, my u is x to the 6th. And while we're at it, we need to do u sub. Let's do du is equal to 6x to the 5th times dx. Hey, I have an x 5th times dx in my numerator, but I do not have a 6. That's fine. It's a coefficient, so I can factor that out. The 5th times dx. All right. Awesome. Let's go ahead and make my substitutions, right? So this is just the integral of right? And this, right, we said this is the same thing as this, all right? So if you want to go ahead and take that step, right? This is just, that's all it is, right? Meaning this is going to be 1 over the square root of 1 squared minus u squared times x to the 5th times dx. That is just du over 6. Right, du over 6, that is just 1 over 6. And I can factor that out, right? I can factor that out. So this is 1 over 6 integral of 1 over the square root of 1 squared minus u squared times du. That is the square root one. This is our third one we've been doing. So I know this is arc sine, all right? And there's a reason why I'm doing these, all right? So this is 1 over 6 arc sine of u over a, where a is just 1. C. All right. But I know what u is, right? U is just x to the 6, right? So in other words, my answer here would be 1 over 6 arc sine to the 6th over 1, which is x to the 6 plus c. And that there would be my final answer. We have a different one now, right? Right, we have a different one. Right, remember, so one thing you may notice, right? You'll get familiar with these the more you end up doing. All right, so one thing you may end up wanting to do is, you know what, I'm gonna do u sub. Right, so u is equal to x squared plus 1, because I noticed that the degree denominator is greater than the top. So du equals 2x. Let me divide by 2. So du over 2 equals x dx. So you're like, hey, I got an x on the top, but not really though, right? And not really. What you have on the top is an x variable added with another coefficient, all right? So in other words, this is not going to work because you need to have exactly what's on the top, all right? Not just part of it. So the u sub is not going to work here, all right? A great thing to do, right? We noticed before, we said, hey, if you have a polynomial on top, right, divided by just one thing, you can rewrite that by dividing everything in the top by that one thing. So technically, I'm gonna do the same thing here, right? I'm gonna go ahead and do the same thing here, but I'm going to treat that denominator, x squared plus 1, as a one piece, as an entire piece. I'm going to treat it as just a full piece, right? So in other words, what I have here is the integral of 3x over x squared plus 1 plus 3 plus times d, right, plus 3 over x squared plus 1. Why does this work, you may ask? Whenever you're adding fractions, if they have the same common denominator, all right, they combine, the numerators combine, and the denominator stays exactly the same, right? So which we can go from back to back to that, right? So pretty straightforward, all right? Pretty straightforward. I can go ahead and distribute or apply that integral to both parts, right? So in other words, I can look at dx over x squared plus 1 times dx, and I can look at the integral of 3 over x squared plus 1 dx. All right. Working on, let's go ahead and work on the left one, right? Let's go ahead and work on the left one. Let me factor out that 3. You may notice, hey, the degree in the bottom is exactly one higher than the top, and the top is just one variable. This is the previous section. So in other words, let u equals x squared plus 1. Therefore, du is equal to 2x times dx. Divide both sides by 2. So du over 2 is equal to x dx, which I do have that. So in other words, this now becomes 3 integral of 1 over u times du over 2, right? U over 2. Meaning I can factor out that 2. This is 3 over 2 integral of 1 over u times du, right? And remember, if you have just 1 over u, let's not do u to the negative 1. And the reason I'm giggling saying this because that used to be, I used to do that all the time, right? I would never get it through my head, right? So I do not want you to spend like 5 minutes doing this step and wondering what's wrong. Just remember, one to the integral of 1 over u is natural log of u. All right, and I know what u is. U is 3 over 2 natural log of, what is that? X squared plus 1. Wow, so that's just part of it, right? That's just part of it. All right, so let's go ahead and do the right side, right? Let me go ahead and zoom in, then I'll zoom out. Hey, okay, again, I'm gonna want to factor out that 3. So I have 1 over x squared plus 1 times dx. Hey, this looks familiar. Just look at very familiar. This is arctan, right? Arctan tells us that the integral, go ahead and just bring this over, right? Right, so the arctan one is a little bit different, right? The one is a little bit different than the arcsine, right? Where it's very similar to the arcsecant as well, but where on the outside you also have to divide by a. All right, you also have to divide by a. So in other words, my u here would be x, my a here would be 1. Okay, so in other words, this is 1 over a, which is 1, times arctan of u, right, which is x, over a, which is 1, plus c. So this is 3 arctan of x plus c, meaning your final answer, right? Right, you have to combine both of these two, right? Your final answer would be 3 over 2 natural log of x squared plus 1 plus 3 arctan of x plus c. This here would be your final answer. The main thing here, right, was to split that integral into 2 parts, right? Split that into 2 parts, right? All right, a little more things going on here, right? A few more things going on here, right? It's quite the jump, right? Quite the jump. All right. So possibly a few things that I want to go ahead and do here is I want to go ahead and factor that -2. All right, I want to go ahead and factor this -2. So this here would be -2 integral bounded between -1 and 1 of inverse cosine of x over 1 minus x squared times dx. Right. One thing you may want to do is do the split, right? We can do the split, right? -2 integral of -1 to 1 of cosine of x times 1 over 1 minus x squared times dx, right? I'm just splitting everything up. All right. One thing you may have noticed is, yeah, I need to do u sub here, right? This you would have to do u sub. So u is going to be my inverse cosine, because you know what is the derivative of inverse cosine, right? If you look at the left-hand side of your sheet, all right, the left-hand side of your sheet, they give me they give me the derivative for inverse cosine, right, on the inverse trig, right? The derivative for this, right, the derivative of this is -1 over square root of 1 minus x squared times dx. I have everything almost except the negative, so let me go ahead and divide a -1 out. So in other words, negative du is the same thing as 1 over 1 minus x squared times dx. Right, now I can go ahead and make those appropriate substitutions. Right, so this is -2 integral bounded between -1 and 1 of u times -du. All right, so in other words, this is -du, -2 minus u times du, right, between 1 and 1. I can factor out that negative, right, which ends up giving me negative times the negative will be a positive. So this is 2 integral bounded between -1 and 1 of u du. All right. Let's see what else. What else can I go ahead and do? All right. So one question you might ask is, hey, what if I decided not to factor out that negative in the beginning? What if I decided to leave it inside because I knew that the derivative of inverse cosine had a negative value? That's fine, right? You can go ahead and do that. If you have if you can see, if you're able to see it far ahead, then yeah, definitely go ahead and do that, right? It's up to you, right? It's up to you. And the more of these that you do, the more of that sight you're going to be able to have, right? Being able to see a few steps ahead to see what's going to work with you. All right. So what I need to go ahead and do here is integrate this, right? Integrate this. This is pretty straightforward. This is to integral between -1 and 1 of u squared over 2. Oh, wait, what am I doing? I already took the integral. So the integral would be u squared over 2 bounded between 1 and -1. Those 2's cancel out, right? Those 2's cancel out, leaving me with u squared bounded between 1 and -1. All right. But I know what u is, right? What is u? U is inverse cosine, right, of x. So in other words, inverse cosine of x, or arc cosine, squared bounded between 1 and -1. Right, so this here ends up giving me arc cosine of 1 squared minus arc cosine of -1 squared. Right. And if you have your cheat sheet, right, whenever we're dealing with inverse cosine, right, we know from trig, inverse cosine only exists in quadrants 1 and 2. All right, it only exists in quadrants 1 and 2. Right, and I believe I have that information for you in the. Let me go ahead and pull it up real quick. I believe I posted it up as a worksheet to print out, right? Specifically, it was going to be for this section, bounds, right, for your inverse cosine. Yeah, it's right here, right? So on the trig sheet, right, in Blackboard, specifically, I'm looking at this top part, right? I'm looking at this part here, right, where the inverse cosine, right, exists between 0 and pi. And so in other words, it only exists in the first and second quadrant. All right, so between 0 and pi, right? Let's go ahead and clear this. Very nice. All right, so there's that. So in other words, what I'm asking you here, right? What I'm asking you here is cosine of what gives you +1? Like cosine of what gives you +1? Right? Cosine of what? With degrees, right? You can do degrees of radians, right? I'll let you go ahead and use the. Oh, you know what? Actually, no. Only use radians, right? Only use radians. I only like using degrees, right? If we're dealing with trig itself, just trig class, but use radians, right? So that's going to be 0, right? Because cosine of 0 gives me 1, right? Cosine of 0 gives me 1. All right. And what would be the next value? All right, minus cosine of what gives me -1 within these bounds? Oh, that's pi, and I can use pi. So that's going to be pi squared. This cancels out, so your answer would be -pi squared. And you can leave it like that, right? I don't want you to simplify it, right? I don't want you to do negative times 3.14 squared, right? This here would work. So yeah, very, very, very nice. And I believe that is all I have for y'all today, right? I believe that is all I have for y'all today. There's going to be a lot of use up, right? And I've also linked a lot of the videos to these questions, all right? So please take the time to read the book. If you're watching the lecture, great. And also watch the small, short videos I provided, right? They're usually around 5 minutes, 5 minutes, right? They're pretty straightforward. But that is all I have for you all today. Thank you very much, and I hope you all enjoy the rest of your day. Thank you.